Today we're going to be talking about similar polygons. This is different from what we did before when it was congruent polygons. Alright, so you should remember hopefully that this is the symbol for congruent. Okay, but that means the same shape and same size. Today we're going to be focusing on similar, which is the same shape but it might be a different size. Right, similar. So it's just that wavy symbol. Alright, our first example, list all the pairs of congruent angles. So ABC is similar to DEF. So that means that angle A would be congruent to angle D. Alright, angle B would be congruent to angle E. And angle C would be congruent to angle F. Alright, and so the order matters again when you're writing this. This would be called a similarity statement. Check that the ratios of the corresponding side lengths are equal. So AB over DE, 10 over 15. If we reduce that, we end up with 2/3. Alright, then we have 8 over 12. Divide both of those by 4. We end up with 2/3. And 12 over 18, divide those by 6, and we end up with 2/3. All of the corresponding sides must be proportional for it to be a similar polygon. Write the ratios of the corresponding side lengths in a statement of proportionality. So all we're saying is AB over DE, that proportion equals BC over EF, which equals AC over DF. Here's your first video problem. Okay, I'd like you to list all the pairs of congruent angles, write the ratios of the corresponding side lengths, and a statement of proportionality. That's really similar to what we just did on the last problem. So pause the video and write down the answers to this. Okay, example 2. Determine whether the polygons are similar. So if they are similar, then all of the sides should be proportional. So if I check AB over JK, which is 14, reduce that, I could divide them both in half, so I'd get 4 over 7. BC over KL, well, that's going to be the same thing, 4 over 7. 8 over 14, wow, the same thing, amazing, isn't it? And then the last one, 12 over 21. I can divide those both by 3, and I should get 4 over 7. Alright, so they are all proportional. So then that means that they are similar. So be careful with their order here. It looks like A, B, C, D is similar to J, K, L, M. And now find the scale factor of A, B, C, D to J, K, L, M. So that would be 8 to 14. Take a side length of A, B, C, D, a side length of J, K, L, M. Alright, or we can reduce it. It would be 4 to 7. Alright, you can write it like that, remember? You could also write it as this, or you can also write it as 4 to 7. So the scale factor of ABCD to JKLM, the order matters here. Example 3, these triangles are similar, so find the value of x. Alright, so we could do 5 over 10, since their corresponding sides, equals 13 over x. You don't have to do this, but I'm going to save a little bit of thought, alright? That's the same as 1/2. So now I could cross multiply. 2 times 13 is 26. 1 times x is x. So the value of x here would be 26. This will be something that we'll see a lot where we could set up proportions using the similar triangles. Here's your next set of video problems. Remember, scale factor of LMNP to FGHJ, the order matters. Okay, and use that scale factor to find the value of x. And you can assume here that JFGH is similar to PLMN. Okay, you can assume that these two shapes are similar. Next one, there's a lot of words here, but basically all it's saying, if you have two similar polygons, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Alright, so if this was 4, 4, 4, and 4, and this was 7, 7, 7, and 7, the ratio from the first one to the other one would be 4 to 7. The ratio of their perimeters should also be 4 to 7. So if you add these up, okay, 4 times 4, 16, 7 times 4, 28. We could divide both of those by 4 and we end up with 4 to 7. So the ratio of the sides is equal to the ratio of the perimeters. That's a really important idea here. Okay, ratio of the sides is always going to be equal to the ratio of the perimeters. Ratio of the perimeters. Okay, so don't worry about filling this in here, because I explained it a different way, so that's fine, just ignore that. Okay, so we have a basketball court here. The new court, it says, will be 20 feet wide and 25 feet long. The old court was similar in shape, but was only 16 feet wide. Find the scale factor of the new court to the old court. Alright, so this is our old, this is our new. The scale factor of the new to the old would be 20 to 16, but we could divide them both by 4, so it would be 5 to 4. Find the perimeters of the new court and the old court. Well, the new one, we already know all the sides, so I could just add those up. 50 and 40 makes 90. Alright, perimeter of the new court is 90 feet. The perimeter of the old court is in the same ratio as the sides. So 5 over 4 equals 90 over x. We cross multiply here. 4 times 90 is 360. Okay, that equals 5x. Divide by 5. And I believe it's 72. Correct me if I'm wrong there. Alright, so the old perimeter would have been 72 feet. So I did all of that without having to find the actual side. Alright, so this is just another method of completing these problems. Example 5. This shows us that not only are sides proportional, but also other segments such as altitudes, medians, mid-segments, all of those are going to be proportional as well. So we have FGH, the whole triangle, is similar to JGK. Alright, so it looks like the length of the whole side down here is 16. The length of the whole side down here is 10. So all of the sides and the special segment should be in a proportion of 8 to 5. Alright, and so then the altitude of this triangle is 14. So to find the altitude GL, we're going to set up 8 to 5 equals, alright, GL, or the altitude, you can have X or A, over 14. Cross multiply here. So it'd be 80 and 32, 112, equals 5 times GL. And we can divide. And you can leave it as a fraction, alright, or a decimal. I know you guys love decimals. 1/12 over 5 is GL. Or if you want to put it as a decimal, it'd be 22.4. Alright, here I believe, let me double check. Yep, the last two problems for the video, I want you to find the perimeter of this triangle and try to do it without finding each side. That's too much work. You should be able to look at the scale factors. Alright, if I tell you that WXY is similar to PQR, you should be able to find the scale factor and then find the perimeter. And this one, WXY is similar to PQR. Finish these up and compare it with a neighbor in class.